Imagine drifting silently through an endless expanse where darkness reigns, and the only light is the ghostly shimmer of distant bioluminescence. Welcome to the Abyssal Plains, a vast, silent world hidden deep beneath the ocean's surface. In this realm, where the pressure of the water could crush a submarine and the temperature hovers near freezing, nature creates a scene that is both haunting and mesmerizing. Today, we embark on a journey into this underwater frontier, where every grain of sediment tells a story of ancient time and every quiet corner hides mysteries waiting to be uncovered. The Abyssal Plains are among the Earth's most expansive landscapes, lying at depths of around 3,000 to 6,000 meters. They stretch over tens of thousands of square kilometers and are celebrated as some of the flattest, most featureless regions on our planet. Unlike the dynamic, churning surface of the ocean, these plains are remarkably still, a vast, undisturbed carpet of fine sediment that has slowly settled over millions of years. Imagine a place where time itself seems to have paused, and every moment is filled with a profound, almost sacred silence. The silence here is more than just the absence of sound. It's a palpable, almost otherworldly stillness. In the Abyssal Plains, the cacophony of life that we are familiar with on the surface is replaced by a deep, enveloping quiet. This silence isn't empty. It is the sound of slow processes, the soft whisper of sediment shifting imperceptibly over millennia. Occasionally, a small ripple in the sand or the gentle fall of a marine snow particle creates a transient disturbance, reminding us that even here, life moves, albeit in a languid, deliberate dance. Despite the crushing pressure and the perpetual darkness, life finds a way to flourish on the Abyssal Plains. Here, unique creatures have adapted to one of the most extreme environments on Earth. Consider the humble sea cucumber, a creature that shuffles along the seafloor, digesting decaying organic material that drifts down from the surface. Its slow, methodical movements are a study in persistence and adaptation. A small, living testament to life's ability to thrive even in the most challenging conditions. Another fascinating resident is the deep sea sponge, which over time creates intricate, almost architectural forms out of its simple structure. These sponges serve as both shelter and a source of food for other specialized creatures. Together, they form a delicate ecosystem, one that is interconnected in ways we are only beginning to understand. It is a realm where every organism, no matter how small, plays a critical role in the slow, deliberate symphony of the deep. Beyond the living, the Abyssal Plains themselves are a geological canvas. Over millions of years, fine particles of clay and silt have settled onto the ocean floor, creating layers that act as time capsules of Earth's history. Imagine unrolling an ancient scroll where each layer tells a chapter of our planet's story. From the remnants of prehistoric plankton to traces of long-extinct species. These sediments are not just inert dust, they are archives that, if read correctly, can reveal shifts in climate, changes in ocean circulation, and even the impact of ancient volcanic events. Consider, for example, a section of the plains where a sudden, thicker layer of sediment might indicate a period of increased volcanic activity or a massive plankton bloom. To the untrained eye, it's just a layer of mud, but to a scientist, it's a record of the Earth's dynamic past, a silent chronicle etched in fine particles. What makes the Abyssal Plains so fascinating isn't just their physical characteristics. It's the mystery that permeates every inch of this silent world. For decades, scientists have puzzled over anomalies detected in these depths, strange low-frequency sounds, sometimes captured by deep sea hydrophones, hint at processes or creatures unknown to us. Are these the subtle movements of sediment interacting with ancient geological faults? Or could they be the distant calls of organisms adapted to the unyielding darkness? These unanswered questions add an extra layer of intrigue, inviting us to ponder the unknown. In some parts of the plains, the sediments hide buried treasures, remnants of shipwrecks, lost cargoes, or even relics of ancient civilizations that somehow found their way to these remote depths. Although rare, these discoveries remind us that even in the most isolated places, history can resurface in the most unexpected forms. Beyond the inherent mystery, the abyssal plains play a crucial role in our planet's ecological balance. They act as one of the largest sinks for carbon dioxide, as organic material that sinks from the surface is stored away in these deep layers. This process, known as the biological pump, is a silent yet powerful mechanism that helps regulate our global climate. In a way, the quiet, unchanging plains are not just a backdrop for life. They are active participants in the Earth's intricate system of life and climate regulation. This understanding prompts us to consider the vast, interconnected nature of our planet. The seemingly isolated silence of the deep is, in fact, part of a global network that sustains life. Every particle that settles on the abyssal plain is a testament to the continuous cycle of life, decay, and renewal. A cycle that spans from the bright surface waters to the darkest depths of the ocean. As we journey through this silent world, it becomes clear that the abyssal plains are more than just a barren, lifeless expanse. They are a realm of quiet wonders, a place where the slow passage of time and the persistence of life come together in a delicate balance. It is here that we are reminded of the vastness of nature and the limits of our own understanding. The silence, far from being a void, is rich with stories, each whispering secrets of a world that is both ancient and ever-changing. Picture yourself in a small submersible, gliding slowly over the smooth, sediment-covered floor. Outside, the water is dark and unyielding, but inside, a sense of peace and profound curiosity envelops you. In that moment, you realize that the true marvel of the abyssal plains lies not only in their physical features, but also in the infinite mysteries they hold. Silent world that invites us to listen, learn, and dream. In the end, the abyssal plains teach us about the beauty of silence and the allure of the unknown. They remind us that even in the quietest corners of our planet, life endures, history is written, and mysteries abound. As you drift off to sleep, let the tranquil imagery of these vast, silent plains lull your mind into a peaceful reverie. Embrace the deep, quiet wonder of the ocean's hidden world, and allow yourself to be carried away by the timeless, silent melody of the deep. Imagine plunging into a realm where sunlight never reaches, where crushing pressures and perpetual darkness create an alien landscape. This is the world of deep ocean trenches, the Earth's most mysterious and extreme environments. We're going to embark on a journey into these abyssal depressions, exploring how they form, what secrets they hold, and why they fascinate scientists and explorers alike. Deep ocean trenches are essentially colossal scars on our planet's surface. They form at convergent plate boundaries, where one tectonic plate dives beneath another in a process known as subduction. Think of it as a giant, slow-motion collision between pieces of Earth's crust. As the denser oceanic plate sinks into the mantle, it creates a long, narrow depression in the ocean floor. These trenches can extend for thousands of kilometers, yet they are surprisingly narrow, often just a few dozen kilometers wide. Perhaps the most famous of these is the Mariana Trench, home to the Challenger Deep. The deepest point on Earth at nearly 11,000 meters below sea level. To put that in perspective, if Mount Everest were dropped into the Mariana Trench, its peak would still be more than a kilometer underwater. This extreme depth subjects anything that ventures there to pressures of over 1,000 times the atmospheric pressure at sea level. A force so immense that even advanced materials must be engineered specifically to withstand it. But the wonders of deep ocean trenches extend far beyond their mind-boggling depths. These chasms are hotspots of geological activity. Along their steep, rugged slopes, hydrothermal vents spew superheated, mineral-rich water into the frigid darkness. These vents create unique ecosystems, where life thrives without sunlight. Strange organisms, such as bioluminescent jellyfish, tube worms, and even bizarre crustaceans, depend on chemosynthesis, a process that converts the chemicals from these vents into energy, much like plants use sunlight. Take, for example, the tiny amphipods that inhabit these dark regions. Despite their minute size, they play a crucial role in the trench ecosystems. In the Mariana Trench, thousands of amphipods scavenge the sea, feeding on marine snow, a continuous shower of organic debris that falls from the upper layers of the ocean. In this inhospitable environment, every morsel of food is precious, and these creatures have adapted to survive on the smallest energy sources. Deep ocean trenches are not only geological marvels and biological oases, they also hold historical and cultural mysteries. Over the years, ghost ships and sunken wrecks have been discovered in these eerie underwater corridors. In some regions, legends speak of ancient lost cities swallowed by the sea, a tantalizing blend of myth and mystery that continues to inspire filmmakers, writers, and deep-sea explorers. The formation of these trenches is a dramatic chapter in Earth's tectonic story. Consider the process that gives birth to them. As the oceanic plate ages, it cools, becomes denser, and eventually loses buoyancy. When it collides with another plate, often one carrying lighter continental crust, it bends downward, creating a trench. This process doesn't occur overnight. It is the result of millions of years of gradual motion. In fact, scientists estimate that the oceanic crust can travel from a mid-ocean ridge to a trench in just 150 million years. A blink of an eye on the geological timescale. Let's look at another remarkable example, the Tonga Trench. Located in the South Pacific, the Tonga Trench is not only one of the deepest on the planet, but also one of the most seismically active regions, with plates colliding at rates exceeding 20 centimeters per year in some spots. The Tonga Trench is a veritable earthquake factory. This activity makes it a natural laboratory for understanding subduction processes and the forces that shape our planet's surface. Yet, for all the dramatic geological forces at work, deep ocean trenches remain some of the least explored places on Earth. Despite modern advances in robotics and sonar technology, we have mapped only a fraction of the seafloor in high resolution. Initiatives like SEEBD 2030 aim to change that by creating a detailed global map of our ocean floor. With only about a quarter of the seafloor mapped in modern detail, the trenches represent a vast frontier of undiscovered science, holding clues to everything from Earth's climate history to the origins of life itself. Exploration of these depths has not been without peril. In 1960, the bathyscaphe Trieste made history by descending into the Challenger Deep, and later, more advanced submersibles like James Cameron's Deep-Sea Challenger and Caladan Oceanic's DSV, limiting factor pushed the boundaries even further. Each dive provides not only breathtaking footage of alien seascapes, but also invaluable scientific data. During one such descent, explorers even found a discarded beer bottle, a stark reminder of human impact, even in the remotest corners of our planet. The biotic communities in deep ocean trenches are as unique as the landscapes themselves. In the perpetual darkness, many creatures have evolved extraordinary adaptations. Some fish, like the Haddle snailfish, have soft, gelatinous bodies that can withstand immense pressures. Others, like certain species of sea cucumbers and anemones, have developed ways to slowly process the sparse organic material that reaches the trench floor. These organisms not only survive but also contribute to a delicate and finely balanced ecosystem that is incredibly sensitive to changes in temperature, pressure, and even pollution. Moreover, deep ocean trenches offer a window into Earth's past. Sediments that accumulate over millions of years can act as a historical archive, preserving clues about past climate conditions, tectonic shifts, and even catastrophic events. By studying these layers, scientists can reconstruct the geological history of our planet, offering insights into processes that have shaped the continents and oceans over eons. The mystery and majesty of deep ocean trenches remind us of how much remains unknown about our own planet. These underwater canyons, formed by the relentless, slow churn of tectonic plates, are both a testament to Earth's dynamic nature and a challenge to our understanding. Every dive, every new map, and every sample collected helps to piece together the puzzle of our planet's history. As technology advances and our capacity for exploration grows, we are only beginning to scratch the surface of these profound depths. Deep ocean trenches not only inspire awe with their extreme conditions and bizarre life forms, they also challenge us to think about sustainability and human impact. With increasing interest in deep sea mining and resource extraction, understanding these delicate ecosystems has never been more crucial. In closing, the study of deep ocean trenches is a journey into the unknown, a plunge into a world of darkness and pressure where life finds a way against all odds. It is a reminder of the hidden beauty and mystery that lie beneath the waves, waiting to be explored, understood, and protected. Imagine descending into a world where sunlight is but a distant memory, a realm cloaked in perpetual darkness, where the crushing weight of the ocean's depths meets bursts of unimaginable heat. Welcome to the domain of hydrothermal vents, nature's underwater geysers that transform the seafloor into a landscape of fiery hearts amid the frozen abyss. In the deepest reaches of our oceans, along mid-ocean ridges and tectonic boundaries, the Earth's crust is thin and restless. Here, seawater seeps into cracks and fissures, meeting magma hidden beneath the ocean floor. In a spectacular transformation, this water heats up to temperatures exceeding 400 degrees Celsius, yet it never boils away because of the immense pressure that surrounds it. When this superheated, mineral-rich water is forced back into the ocean, it erupts from the seafloor like the breath of an ancient dragon. These eruptions form towering chimneys, colloquially known as black smokers, due to the dark, sooty plumes they emit. Yet, beneath what seems like an environment too hostile for life, an entire ecosystem flourishes. Instead of relying on sunlight for energy, the life around hydrothermal vents harnesses a process called chemosynthesis. Specialized bacteria convert the chemicals spewed from the vents, most notably hydrogen sulfide, into energy. This process creates the foundation for a unique food chain that does not depend on the sun. In these deep, dark waters, chemosynthetic bacteria become the primary producers, feeding a host of extraordinary creatures. Picture, for instance, the giant tube worm, a creature that can extend over 2 feet in length. These tube worms lack a digestive system of their own. Instead, they rely on a symbiotic relationship with the bacteria that live inside them. The bacteria convert the vent's chemical bounty into nutrients, which are then shared with their host. Alongside the tube worms, clams, mussels, and specialized crustaceans have all carved out their niche around these vents, each uniquely adapted to a life where the temperature and chemical composition of the water challenge every known rule of biology. The geological artistry of hydrothermal vents is as mesmerizing as the biology they support. As mineral-rich water cools rapidly after its dramatic exit from the vent, it leaves behind deposits of sulfide and other compounds. Over time, these minerals accumulate to build spectacular chimneys and mound-like structures that continuously evolve. Imagine a natural sculpture garden where each formation is both transient and monumental, a silent chronicle of the dynamic forces at play beneath the ocean floor. Consider, too, the famous vent systems along the mid-Atlantic ridge. When these deep sea vents were first discovered in the late 1970s, they completely upended our understanding of where life could exist. Prior to their discovery, it was assumed that the sun was the only provider of energy necessary for life. Instead, here in the pitch-black depths, life had carved out a thriving existence entirely independent of solar light. The organisms residing here, many of which are found nowhere else on Earth, remind us that life is remarkably adaptable, and that the universe may harbor life in even the most extreme environments, such as on the icy moons of Jupiter and Saturn. As you listen to this narrative, close your eyes and let your imagination wander. Picture the deep ocean floor, where the water is nearly freezing, contrasting starkly with the searing heat of the vent's output. Envision the swirling clouds of mineral particles, jet black from the smokers, or shimmering with lighter hues from white smokers. As they diffuse into the darkness, there is an almost hypnotic quality to these scenes, the rhythmic pulse of water, the soft hiss of escaping gases, and the subtle, eerie glow produced by bioluminescent organisms flitting near the vent openings. The soundscape of hydrothermal vents is an enigmatic symphony. While the environment may seem eerily silent, there is an underlying hum, a gentle bubbling that accompanies the steady release of hot water and the creaking of the shifting seafloor. This quiet, persistent music of the deep serves as a reminder of nature's ability to thrive in places where we might least expect it. Scientists have long been captivated by the mystery and resilience of these ecosystems. Armed with sophisticated submersibles and remotely operated vehicles, RAVs, researchers embark on daring expeditions into these remote regions. Their discoveries are nothing short of revolutionary. Every dive into a vent field uncovers new species, each more astonishing than the last, and offers fresh insights into the complex interplay between Earth's geology and biology. These underwater explorations have not only broadened our understanding of extreme life on Earth, but have also inspired theories about the origins of life itself. Many researchers speculate that the first living organisms may have arisen in similar, chemically rich environments, where energy and raw materials came together to spark life in its most primordial form. The tale of hydrothermal vents is one of paradox and wonder. It is a story where searing heat and icy waters collide, where death and life coexist in a delicate balance, and where the ordinary laws of nature are rewritten. In these hidden realms, every bubbling plume, every shimmering mineral deposit, tells a story of survival against the odds. A story that challenges our conventional views and opens our minds to the endless possibilities that exist beneath the surface of our world. As our journey through the realm of hydrothermal vents draws to a close, take a moment to reflect on the profound mysteries that lie beneath the ocean's surface. These vents are not merely geological curiosities or isolated pockets of life. They are vivid reminders of nature's boundless creativity and resilience. They invite us to look beyond the familiar and to explore a universe where the extraordinary is the norm. So, let the imagery of these fiery vents, set against the backdrop of a frozen, mysterious seascape, carry you away into a state of tranquil wonder. Let the story of these deep, sea marvels inspire your own journey of curiosity and exploration, reminding you that sometimes the most profound mysteries are found in the places we least expect. Now, as you prepare to drift into a peaceful slumber, let the echoes of these underwater tales lull your mind into a serene contemplation of the infinite mysteries of our blue planet. At its core, bioluminescence is a biochemical reaction within specialized cells or organs. A molecule known as luciferin reacts with oxygen in the presence of an enzyme called luciferase. The result, a release of energy in the form of visible light. This process isn't just a random burst of illumination. It's an intricate adaptation honed by millions of years of evolution. The light produced can vary in color, from the soft green glow of fireflies to the eerie blue shimmer of deep sea creatures. And each hue plays a role in the survival strategies of these organisms. Consider the enchanting displays in our own backyards. On warm summer nights, countless fireflies engage in a silent conversation of light. Their rhythmic flashes aren't merely decorative, they serve as signals for mating, guiding potential partners through the dark. Each flicker is a carefully timed invitation, a piece of a complex communication system that has evolved to ensure the continuation of the species. Yet, the wonders of bioluminescence extend far beyond terrestrial fireflies. In the uncharted depths of our oceans, where sunlight fails to penetrate, life has taken an entirely different approach to the dark. Here, the rules of survival demand that organisms either vanish into the abyss or shine brightly to stand out. One of the most iconic examples is the deep sea anglerfish. Dwelling in an environment where every bit of light counts, this creature sports a luminescent lure dangling from its head. By emitting a gentle glow, the anglerfish attracts unsuspecting prey, drawing them into the grip of its formidable jaws. This biological flashlight is not only a tool for hunting, but also a beacon in the vast, pitch-black waters. The ocean offers even more spectacle. On certain nights, coastal waters transform into surreal, glowing landscapes. Disturbances in the water, whether from a boat's wake or a swimmer's movement, can trigger vast colonies of bioluminescent plankton to burst into brilliant blue light. These fleeting illuminations have inspired seafaring legends of ghostly, radiant seas, where the ocean itself seems to come alive with pulsating energy. Scientists suggest that these displays are a natural defense mechanism, confusing predators and drawing attention away from more vulnerable prey. It's a vivid reminder that what we often consider as darkness is, in fact, filled with hidden life and light. Diving deeper into the science, the magic of bioluminescence is all about efficiency. The chemical reactions involved are incredibly energy efficient. Almost all the energy released goes into producing light rather than heat. This contrasts with most man-made light sources, which waste a significant amount of energy as heat. In the quiet isolation of a dark forest or the crushing pressures of the deep sea, such efficiency isn't just advantageous, it's essential for survival. The purposes of bioluminescence are as varied as the organisms that display it. Some species use it as a lure to attract prey, as with the anglerfish. Others, like certain squid and shrimp, flash sudden bursts of light to startle predators, giving them a critical few seconds to escape. In some cases, bioluminescence acts as a social signal, a way for organisms to communicate with one another. During mating rituals, intricate light patterns serve as courtship displays, ensuring that the right signals are sent and received in the dark. Beyond its role in the wild, the study of bioluminescence has sparked innovations that reach far beyond natural ecosystems. Researchers have harnessed these glowing proteins for breakthroughs in medical imaging and molecular biology. By attaching luciferin and luciferase to specific cells, scientists can track the movement and behavior of these cells in real time. This has revolutionized fields like cancer research, allowing for non-invasive imaging techniques that provide unprecedented insight into cellular processes. In environmental science, bioluminescent organisms are being explored as potential indicators of ecosystem health, their light serving as a natural sensor for pollution or other ecological disturbances. There are also more mysterious, almost mythical, manifestations of bioluminescence. One such enigma is the Milky Seas phenomenon, a rare occurrence where vast areas of the ocean appear to glow with a steady, eerie light. For centuries, mariners have reported seeing entire stretches of sea bathed in a ghostly luminescence, as if the water itself were an extension of the night sky. While still not fully understood, recent studies suggest that large colonies of bioluminescent bacteria, working together in harmony, may be responsible for these otherworldly displays. Such phenomena challenge our perceptions of what is possible in the natural world, blending the boundaries between science and folklore. On land, bioluminescence reveals its quieter side. In some forests, hidden among decaying logs and the detritus of fallen leaves, bioluminescent fungi cast a faint glow, a phenomenon sometimes referred to as foxfire. These spectral lights have given rise to countless legends, with tales of enchanted groves and ghostly encounters whispered among those who wander beneath the trees. While the light of these fungi is soft and subtle, its presence adds a layer of mystery to the forest, suggesting that even in decay there is a spark of life. The diversity of bioluminescent life forms is a testament to nature's ability to adapt and innovate. Whether it's the synchronized flashing of fireflies in a summer meadow, the luring light of a deep-sea predator, or the collaborative glow of microbial communities in the open ocean, each instance of bioluminescence tells a story of survival, communication, and wonder. It is a language written in light, a silent symphony that transcends the boundaries of species and habitats. In unraveling these luminous mysteries, scientists are not only expanding our understanding of biology, but are also uncovering potential applications that may transform our technological landscape. Imagine medical diagnostics that use bioluminescent markers to detect diseases early, or environmental sensors that alert us to the slightest changes in ecosystem health. The secrets hidden in these glowing organisms could one day lead to innovations that improve our quality of life, all while deepening our appreciation for the natural world. As we continue to explore the phenomenon of bioluminescence, one thing becomes clear: nature has an unrivaled ability to surprise and inspire. Every flash of light is a reminder of the delicate balance between survival and beauty, a balance that has been maintained through countless generations. The next time you catch a glimpse of a firefly's flicker or witness the haunting glow of bioluminescent waters, take a moment to reflect on the intricate processes at work. These luminous signals are not just random occurrences, they are finely tuned adaptations that speak to the resilience and creativity of life itself. The world of bioluminescence is a brilliant intersection of art and science, a realm where biology and chemistry combine to create a spectacle that is both functional and profoundly beautiful. In exploring these wonders, we not only learn about the survival strategies of diverse organisms, but also gain insight into the broader processes that drive evolution and innovation on our planet. Let's start with the basics. What are blue holes? Picture a skyscraper but underwater. These are sinkholes carved into limestone bedrock during the last ice age, when sea levels were nearly 400 feet lower than today. Rainwater, slightly acidic from absorbing carbon dioxide, seeped into the ground, dissolving the rock over millennia. When the glaciers melted and seas rose, these gargantuan pits flooded, creating portals to a prehistoric world. Take Dean's Blue Hole in the Bahamas. At 6,663 feet deep, it's the deepest known blue hole on Earth. To put that in perspective, if you drop the Statue of Liberty into it, only the tip of her torch would peek above the water. But depth isn't the only thing that chills the blood here. In 2013, freediver Nicholas Meverly attempted a record dive here and never resurfaced. His tragic story underscores the danger lurking in these deceptively calm waters. But here's where it gets even wilder. Blue holes aren't just empty pits. They're layered like a cake. If that cake were made of toxic bacteria, ancient fossils, and water so oxygen-deprived it could suffocate a fish in seconds. The upper layers teem with life: tropical fish, corals, even the occasional shark. But descend past 60 feet and the oxygen vanishes. This anoxic zone is a graveyard. Organic matter, dead plants, and everything sinks here, decomposing slowly in the stagnant water. The result, a buildup of hydrogen sulfide, a gas so poisonous it's lethal to most complex life. In 2019, a team exploring the Great Blue Hole of Belize found something straight out of a horror movie. Below 300 feet, the water turned cloudy with hydrogen sulfide. Their cameras captured conch shells, crab carcasses, and even the remains of a loggerhead turtle, all perfectly preserved in this toxic soup. No scavengers, no decay. It's like walking into a museum where every exhibit died in suspended animation. But why should we care about these underwater mausoleums? Because blue holes are nature's history books. The sediment layers trapped inside them hold clues to Earth's past climates. Pollen grains, volcanic ash, and even ancient hurricane patterns are preserved here. In the Bahamas, researchers drilling into a blue hole's sediments found evidence of a mega drought 3,000 years ago. A drought so severe it may have wiped out entire civilizations. And then there's the life that does survive here. In the oxygen-free zones, scientists discovered mats of purple sulfur bacteria, organisms that thrive on hydrogen sulfide and sunlight. These extremophiles are like the astronauts of the microbial world, surviving conditions that would obliterate most life. But here's the kicker: some of these bacteria are entirely new to science. Their enzymes, adapted to extreme environments, are now being studied for medical breakthroughs, including potential treatments for cystic fibrosis. Let's not forget the caves themselves. Many blue holes are labyrinths of tunnels and chambers, some stretching for miles. Explorers have mapped underwater passages connecting blue holes to inland caves, a network that likely served as shelters for early humans during the Ice Age. In one blue hole off Mexico's Yucatan Peninsula, divers found human bones and fire pits dating back 13,000 years. Were these the remains of rituals? Accidents? We still don't know. Exploring these caves isn't for the faint of heart. Divers risk nitrogen narcosis, a hallucinogenic effect caused by deep water pressure, and the ever-present threat of getting lost in pitch-black tunnels. In 2021, a team using advanced sonar discovered a hidden chamber in Dean's Blue Hole filled with stalactites. How? Stalactites form in air-filled caves, which means this chamber was above water during the Ice Age. It's a snapshot of a time when this abyss was a dry, hollow mountain. But blue holes aren't just about death and darkness. Their sunlit shallows are biodiversity hotspots. In the Bahamas, endangered sea turtles nest on nearby beaches, and juvenile sharks patrol the blue hole's edges. These ecosystems are so rich that conservationists are fighting to protect pollution and overfishing. After all, losing a blue hole isn't just losing a pretty diving spot, it's erasing a chapter of Earth's history. So, what's left to uncover? Plenty. We've only explored about 20% of the world's known blue holes. What lurks in the rest? New species? Clues to ancient human migration? Or perhaps evidence of geological processes we can't yet imagine? The enigma of the blue holes reminds us that our planet still holds mysteries that defy explanation. They're reminders of how much we don't know, and how much is left to discover. So the next time you see the ocean's surface, remember, below that glassy facade lies a world where time stands still, where life and death dance in the darkness, and where the secrets of our past are waiting to surface. The ocean is a keeper of secrets, a silent witness to countless voyages that ended in tragedy, madness, or the unexplainable. These aren't just stories, they're scars on the surface of history. Ghost ships and sunken wrecks, abandoned by time, yet heavy with questions that refuse to sink. Let's begin with the Mary Celeste. December 1872. A merchant ship is spotted drifting near the Azores, sails taut with wind, cargo of industrial alcohol perfectly intact, but the crew, the captain, his wife, their toddler daughter, and 7 seasoned sailors, are gone, vanished. A half-eaten meal sits in the galley. The crew's personal belongings remain untouched. No signs of struggle, no leaks, no logical reason to abandon ship. Theories: a rogue wave, fumes from the alcohol igniting panic, or something darker. The lifeboat was missing, but why flee a seaworthy vessel into open ocean? The Mary Celeste became a blueprint for maritime mystery, a riddle written in salt and silence. Then there's the SS Cotopaxi. In 1925, this coal carrier left Charleston for Havana and disappeared into the Bermuda Triangle's lore. For 95 years, it was just another ghost story, until 2020, when wreckage matching its description was found off Florida's coast. But the discovery raised more questions. The Cotopaxi's final distress call reported a fire in the hold. Did an explosion doom the ship? Or was it the Triangle's infamous reputation at play? Why did it take a century to find a wreck in relatively shallow waters? The ocean, it seems, enjoys its games. But not all legends stay legends. The Flying Dutchman, a phantom ship doomed to sail eternally, haunts sailors' tales since the 1600s. Its sighting, a death omen. But strip away the myth, and you'll find the Cape of Good Hope, a real-world ship graveyard. Treacherous currents and freak waves destroyed countless vessels here, their crews lost to the depths. In 1941, a Nazi U-boat captain even logged a sighting of a phantom brig with glowing sails. Was it a hallucination, or proof that some stories outlive their skeletons? Now, fast forward to 2006. The MV Joyatar, a fishing vessel missing for 5 weeks, is found adrift in the South Pacific. Clock stopped, fuel tanks fault, radio set to the emergency channel, but the microphone ripped away. Medical supplies laid out as if mid-crisis. But the 25 crew members, No bodies, no struggle. Stranger still, the ship was still afloat. Theories, parrots, a mutiny, or something unnatural. The hull bore deep gashes, as if clawed by something massive. Some point to the bloop, a mysterious, otherworldly sound recorded in the Pacific, attributed by conspiracy theorists to creatures beyond our understanding. But few tales curdle the blood like the SS Orang Medan, 1947. A Dutch merchant ship near Indonesia sends a frantic sus. All officers dead. Entire crew dead. Rescuers arrive to a nightmare. Bodies sprawl on the deck, faces frozen in terror, eyes wide, mouth screaming silently. No wounds, no poison. No explanation. Then, the ship explodes, sinking into the Java Sea. Skeptics call it a hoax, but declassified CIA files reference the incident. Was it a chemical leak, a clandestine weapons test, or something older, something that shouldn't exist in the lightless depths? Science fights to unravel these enigmas. Take methane hydrates, gas trapped under the sea. When released, they create boiling columns of bubbles that lower water density so drastically, ships drop like stones. Could this explain the Marie Celeste's abandonment? Or modern cargo ships found with inexplicable holes? Then there's dead water, a phenomenon where hidden waves drag ships backward, as if gripped by an invisible hand. Sailors once blamed curses. Today we call it physics. But that doesn't make it less terrifying. Yet the most haunting question isn't how these ships vanished, it's what they leave behind. Consider the SS Valentia, a 1906 passenger ship wrecked off Canada's coast. Years later, lifeboats were found in a cave 40 feet above the tide line, as if tossed there by a vengeful sea. Or the MV Alta, abandoned in the Bermuda Triangle in 2004, only to reappear in 2020, 16 years later, crashing onto island shore. How did it drift 4,000 miles, dodging icebergs and hurricanes, without a crew? The ocean doesn't answer. These wrecks are time capsules. In 2015, divers explored the SS Thistlegorm, a Dum-Dum-Duu cargo ship sunk in the Red Sea. Its holds still cradle trucks, rifles, and even leather boots, preserved in eerie perfection. In Japan's Truk Lagoon, a ghost fleet of WDI warships lies in shallow water, their decks littered with gas masks and sake bottles, their holds holding skeletons of tanks. These aren't wrecks, they're museums of the damned. But here's the truth: ghost ships aren't about the past. They're about us. They force us to confront how little we control, how vast the unknown remains. The ocean doesn't care about our logic. It keeps its secrets jealously, whispering only to those brave, or foolish, enough to listen. So the next time you stand on a shore, watching the horizon, remember, beneath those waves, in the crushing dark, lies a world where stories don't end. They wait. Our journey begins with a question that has long intrigued historians and adventurers alike. Could there have once been thriving metropolises, vibrant centers of culture and innovation, only to be erased in a single, catastrophic event? One of the most famous examples is the tale of Atlantis. Described by Plato over 2 millennia ago, Atlantis has become the emblem of lost civilizations. According to the legend, this advanced society flourished with remarkable technology and wisdom, until a cataclysmic disaster submerged the entire island beneath the ocean. While no definitive archaeological proof has yet been found, the enduring allure of Atlantis lies in its blend of myth, mystery, and the tantalizing possibility that our planet holds secrets far deeper than the Mariana Trench. Beyond the story of Atlantis, numerous accounts from diverse cultures suggest that the phenomenon of submergence is not confined to a single myth. Consider the ancient city of Thonis Heracleion, once a bustling trading hub in the Nile Delta, rediscovered in the early 21st century by underwater archaeologists. This Egyptian city had slipped from historical records until sonar imaging and scuba exploration unveiled its sunken streets and towering statues. The ruins, now resting on the sea, offer tangible evidence that some urban centers were indeed swallowed by the sea, likely victims of shifting river channels and gradual sea level rise over centuries. Across the globe, legends abound. In Brittany, France, there is the myth of Wise, a city said to have been built on a series of islands and ultimately engulfed by the ocean as a divine punishment. Similarly, in the coastal regions of India, ancient texts recount the story of Dwarka, a city associated with the Hindu deity Krishna. Recent underwater surveys off the coast of Gujarat have uncovered structures that some researchers believe could be linked to this legendary city. While the evidence remains contested, these discoveries fuel a broader discussion about how natural forces, like tectonic shifts, volcanic eruptions, or rapid sea level changes, could erase entire civilizations in the blink of an eye. What makes these tales so compelling is not merely the loss of buildings and monuments, but the sudden disappearance of entire ways of life. Imagine a society at the height of its cultural and technological prowess, thriving along the coastline, only to see its achievements and traditions vanish beneath turbulent waters. The destruction of such cities raises profound questions about the resilience of human societies and the unpredictable power of nature. One might wonder what lessons can be drawn from these submerged cities. For one, they serve as stark reminders of nature's relentless force. Modern coastal cities face similar threats: rising sea levels, increased storm surges, and the unpredictable impacts of climate change. While today's technology offers us the means to prepare for or even mitigate such disasters, the legends of these lost cities remind us that human progress can be fragile in the face of nature's might. Yet, the allure of these ancient ruins is not solely a cautionary tale. It also ignites the spark of adventure and exploration. Underwater archaeology has made incredible strides in recent years, aided by advanced technologies like sonar mapping, remotely operated vehicles, ROVs, and even autonomous underwater drones. These tools allow researchers to peer into underwater landscapes that were once thought inaccessible, unveiling secrets buried under layers of sediment. Every discovery, whether it's a fragment of pottery, an inscription on stone, or the silhouette of an ancient column, adds a piece to the puzzle of our shared history. Consider, for example, the submerged ruins near the Greek coast at Pavlopetri. Often cited as one of the oldest submerged cities in the world, Pavlopetri dates back over 5,000 years. Its labyrinthine network of streets, homes, and public buildings challenges our understanding of ancient urban planning and social organization. Here, the interplay between myth and reality becomes strikingly clear. While many of these sites were once dismissed as mere legends, scientific investigation is gradually revealing a historical basis for these stories. In exploring these underwater worlds, researchers face immense technical and logistical challenges. The ocean is an unforgiving environment, with high pressures, limited visibility, and the constant threat of corrosion to delicate instruments. Yet, each dive is a leap into the unknown, a quest to recover the narratives of people who lived long before modern records were kept. These explorations are not just academic exercises. They are epic adventures that echo the tales of old, filled with suspense, discovery, and the promise of rewriting history. The legends of submerged cities also invite us to reflect on the nature of time itself. Civilizations that once flourished with art, science, and philosophy have left behind only traces. Riddles carved in stone, relics encased in marine sediment, and stories passed down through generations. As we piece together these fragments, we begin to see a picture of human civilization that is both resilient and ephemeral. The ocean, in its vastness, holds the records of countless cultures that have come and gone, each contributing to the mosaic of our collective past. In many ways, the study of lost underwater cities is a journey into our own identity. It forces us to confront the limits of human achievement and the inevitability of change. Yet, it also offers a glimpse of hope, a reminder that even in destruction, there is a chance for rebirth and renewal. New discoveries continue to surface, challenging our assumptions and inspiring us to look at history not as a static record, but as a dynamic tapestry woven over millennia. To conclude, the mystery of ancient, Submerged civilizations is a testament to both the grandeur and vulnerability of human endeavors. Whether it's the enigmatic legend of Atlantis, the rediscovered majesty of Thonis, Heraclean, or the disputed relics of Dwarka and Pavlopatri, each story invites us to dive into the depths of history and wonder about the worlds that once were. In uncovering these lost cities, we not only honor the memory of those who built them, but we also illuminate the path toward understanding the forces that continue to shape our own destiny. Beneath the restless waves lies a world of secrets and sounds that defy our understanding. In the silent depths of the ocean, scientists have recorded mysterious noises, signals that challenge our notions of natural phenomena and spark our imagination about what lurks beneath. Not long ago, an ultra-low-frequency sound known as the bloop captured the attention of researchers worldwide. Detected by an array of underwater listening devices, this powerful noise traveled thousands of kilometers through the ocean. Its sheer intensity and enigmatic nature led many to wonder if it was the call of a colossal unknown creature, a living relic from an ancient era. Yet, as investigations unfolded, the sound's characteristics hinted at something more elemental and natural, yet unusual. Acoustic event that the ocean itself can produce. What makes the bloop so compelling is its distinct signature. Recorded in the deep, dark expanse of the Pacific, it exhibited a rapid rise in volume followed by a long, resonant decay. Such traits are reminiscent of natural phenomena like icequakes, where massive slabs of ice crack and fracture under the weight and pressure of polar environments. Sound travels incredibly efficiently underwater, allowing these low-frequency signals to echo across vast distances. This explains how a sound produced in one remote part of the ocean could be detected across continents. The bloop is just one movement in a broader symphony of mysterious underwater sounds. Other signals, often less dramatic in intensity but equally puzzling, have been recorded over the years. Some of these include rapid, sweeping noises that seem to mimic the call of deep sea creatures, while others present as rhythmic pulses that defy current scientific explanation. In several cases, researchers have noted that these sounds do not match any known marine animal communication or geological process. For example, a series of short, ascending chirps, sometimes referred to as upsweeps, has been detected in different regions of the world's oceans. While some initially attributed these signals to marine life, the precision and consistency of their patterns hint at underlying physical phenomena that remain largely unexplained. Could they be the result of underwater volcanic activity, or perhaps the shifting dynamics of tectonic plates? Or might they even be linked to complex interactions between the ocean's temperature layers and pressure gradients? One prevailing theory suggests that many of these sounds originate from the natural fracturing of ice. In polar regions, massive ice shelves are constantly in motion, subjected to extreme environmental forces. When ice cracks, it releases energy in the form of sound waves, an underwater thunder that can traverse entire ocean basins. Such icequakes provide a compelling explanation for events like the bloop. Yet, the possibility remains that not every mysterious sound can be neatly categorized under one phenomenon. Another school of thought points to underwater volcanic activity. The ocean floor is a dynamic landscape, punctuated by hydrothermal vents, fissures, and submarine volcanoes. When these geological structures shift or erupt, they can produce acoustic signals that are both unexpected and powerful. The rhythmic pulses of some unexplained signals could, in fact, be the sonic signatures of these undersea events, a reminder of the planet's restless interior. There's also an alluring, albeit more speculative, idea that some of these sounds might be the communication of undiscovered marine species. The ocean is home to countless creatures that have evolved in isolation from the surface world. It is not beyond the realm of possibility that some of these beings produce sounds that we have yet to understand. However, despite the romantic appeal of this notion, the bulk of scientific evidence points toward natural processes that involve the interaction of water, ice, and the Earth's crust. Central to this exploration is the technology that allows scientists to listen to the deep. Modern hydrophones, sensitive underwater microphones, can capture sounds from across the globe. These devices provide data not only about mysterious noises like the bloop, but also about everyday phenomena that occur in the ocean's vast expanses. By analyzing frequency, amplitude, and the duration of these signals, researchers piece together clues about their origins. Data from these devices have been pivotal in helping scientists construct acoustic maps of the ocean. These maps are like sound portraits that reveal where unusual events are most likely to occur. They allow for targeted studies of regions where mysterious signals are common, enabling researchers to correlate these sounds with specific environmental factors such as ice cover, water temperature, or tectonic activity. Such interdisciplinary approaches are at the heart of modern oceanography, blending geology, biology, and physics into a comprehensive narrative of Earth's underwater dynamics. What makes this exploration so engaging is not just the scientific data, but also the stories that emerge from it. The very idea that the ocean could harbor sounds from an undiscovered creature, or that the Earth itself might be speaking in a language of ice and rock, captivates our imagination. Consider how ancient mariners might have interpreted the deep, rumbling sounds beneath their ships, omens of powerful natural forces at work, or perhaps the whispers of myth and legend. Today, as we listen through our high-tech instruments, those same ancient curiosities are rekindled in a modern context. Each unexplained noise becomes a puzzle piece in the grand mosaic of our planet's history. A history that is written not in words, but in the language of nature itself. The study of these unexplained sounds is an ongoing journey. Every new recording adds depth to our understanding, even as it raises further questions. As research continues, scientists remain both cautious and excited. The balance between skepticism and wonder drives them to refine their instruments, revisit old theories, and explore new hypotheses. In doing so, they not only seek answers but also celebrate the unknown, the unpredictable symphony that plays beneath the surface. For anyone with a curiosity for the mysteries of nature, the oceanic bloop and its enigmatic companions serve as a reminder of how much there is still to learn about our world. They invite us to listen more closely, to question our assumptions, and to embrace the beauty of discovery in a realm where science and wonder coexist. This journey into the depths of sound is far from over. With every pulse and every ripple captured by our listening devices, we edge closer to understanding the intricate and dynamic processes that shape our planet. Whether it is the fracturing of colossal ice shelves, the rumblings of the Earth's interior, or perhaps the secret communications of undiscovered life forms, the ocean continues to sing its ancient, mysterious song, a song that challenges us to listen, learn, and marvel at the wonders of the natural world. By exploring these profound questions, we not only uncover the secrets of the deep, but also connect with the timeless curiosity that drives human discovery. In the end, the unexplained sounds of the ocean remind us that even in the modern age, nature holds mysteries that are waiting to be heard and understood. Deep sea currents are the underwater highways that transport heat, salt, nutrients, and even carbon across the globe. Unlike the familiar surface currents driven by winds and tides, these currents move slowly, guided by differences in water density. A delicate balance between temperature and salinity, often referred to as thermohaline circulation. This process plays a critical role in regulating Earth's climate. For example, the ocean conveyor belt carries warm water from the tropics to the higher latitudes, only to return cold water deep beneath the surface. This slow, yet relentless, movement of water is a testament to nature's intricate design. Consider the journey of a water molecule near the polar regions. As it cools, it becomes denser and sinks into the depths, forming part of a vast undercurrent that travels thousands of miles. Along its journey, it encounters underwater mountains, trenches, and mid-ocean ridges that not only divert its path, but also create isolated pockets of unique ecosystems. These hidden corridors are like secret passageways, unlocking the mystery of how life thrives in the most inhospitable environments. The movement of these deep currents is governed by forces that might seem simple in isolation, but become astonishingly complex when combined. Temperature gradients are a major driver. Warm water is less dense than cold water, causing significant vertical movement in the water column. Similarly, the salt content, or salinity, of water alters its density. When cold, salty water forms in polar regions, it sinks and sets the stage for a slow, moving global cycle. Gravity, in turn, ensures that this denser water is pulled downward, establishing a continuous downward flow in certain parts of the ocean. One striking example is found in the North Atlantic, where surface waters cool rapidly during the winter months. The resulting dense, saline water begins its long descent into the deep, forming a current that slowly makes its way to the other side of the ocean basin. This process is not only a marvel of natural engineering, but also a key player in redistributing heat across the planet, making regions like Western Europe warmer than their latitude might otherwise suggest. Despite decades of oceanographic research, many aspects of deep-sea currents remain shrouded in mystery. Scientists have discovered unexpected patterns in the flow of these underwater rivers, patterns that challenge conventional theories about how the ocean circulates. For instance, in certain regions of the Pacific, anomalous deep currents have been observed that don't seem to follow the predicted paths. Some researchers suggest that these deviations could be caused by underwater topographical features, or even by localized variations in water temperature and salinity that have yet to be fully mapped. There is also the enigmatic phenomenon of deep eddies, whirling masses of water that spin off from the main currents. These swirling vortices can trap nutrients and marine life, creating isolated ecosystems that thrive in the otherwise barren deep. Their unpredictable nature raises fascinating questions about the role these eddies play in nutrient distribution and the overall health of the ocean. Could they be secret incubators for marine biodiversity, or perhaps even regulators of the chemical balance in these dark waters? These questions drive ongoing research and keep the scientific community on the edge of discovery. One of the most talked about examples is the role of deep-sea currents in the global climate system. The North Atlantic deep water, for instance, is a crucial component of the global conveyor belt. Its movement not only affects the temperature of the surrounding regions, but also plays a role in sequestering carbon deep beneath the ocean's surface. As atmospheric carbon dioxide dissolves in the ocean, it is carried by these currents to great depths, where it can be stored for centuries. This natural process is a vital part of Earth's carbon cycle and has significant implications for understanding and mitigating climate change. Another fascinating case comes from the Southern Ocean, where the interplay of deep currents and wind-driven upwelling brings nutrient-rich water to the surface. This nutrient exchange fuels some of the most productive ecosystems on the planet, supporting vast populations of krill, which in turn are a cornerstone of the marine food web. The intricate balance between these deep currents and surface processes illustrates how interconnected our planet's systems truly are, where a shift in one can cascade into dramatic changes in another. Our understanding of these mysterious deep-sea currents has advanced significantly with the advent of modern technology. Sophisticated underwater sensors, autonomous vehicles, and satellite data have enabled scientists to map the ocean floor and track the movement of deep water masses with unprecedented precision. These tools have revealed the complex dance of currents beneath the surface, highlighting areas where conventional models fall short. For example, autonomous underwater vehicles have recorded temperature and salinity anomalies that hint at hidden undercurrents, prompting new theories and further investigations. The technological revolution in oceanography is not just about mapping, it's about storytelling. Each dataset and every recorded anomaly adds a new chapter to the narrative of our planet's hidden dynamics. As researchers continue to explore these depths, they not only expand our scientific understanding, but also fuel our imagination about the untold stories of the deep. The study of mysterious deep-sea currents is far from an academic exercise. It has profound implications for our future. Understanding how these currents work is critical for predicting changes in global climate patterns, managing marine resources, and even safeguarding coastal communities from the impacts of climate change. As the planet warms, shifts in these currents could alter weather patterns, disrupt marine ecosystems, and impact fisheries that millions rely on for food. Moreover, the deep sea remains one of the last uncharted frontiers on Earth. Every new discovery has the potential to revolutionize our understanding of life on our planet. The currents themselves, with their capacity to transport life, sustaining nutrients, and even unknown chemical compounds, could hold the key to unlocking secrets about the origin of life and the resilience of ecosystems in extreme conditions. The mysterious deep-sea currents invite us to rethink what we know about our planet. They challenge us to explore further, to ask new questions, and to remain ever curious about the natural world. As you reflect on this hidden realm, consider how much more there is to learn about the forces that silently shape our world. In the vast, dark expanses of the ocean, every current, every eddy, and every wave tells a story of transformation, balance, and the enduring power of nature. This exploration is not just about science. It's about understanding our place within a larger, interconnected ecosystem. It's a reminder that beneath the familiar blue surface lies a realm full of enigmas waiting to be discovered. Whether you're a seasoned ocean enthusiast or someone new to the wonders of the deep, the study of these currents offers a window into a dynamic and ever-changing world that continues to captivate and inspire. As we continue to decode the secrets of these underwater rivers, the quest for knowledge becomes a journey of wonder and discovery, a journey that ultimately leads us to a deeper appreciation of the intricate and mysterious processes that govern our planet. Far below the familiar blue, a silence prevails, a silence that is punctuated only by the slow, haunting drift of creatures evolved for a world devoid of sunlight. One such being is often whispered about in marine lore, a colossal, spectral form whose presence has sparked both awe and terror. Though rarely witnessed by human eyes, this phantom of the deep has been linked to sightings of giant cephalopods. These elusive titans, with their sinuous tentacles and dark, shifting bodies, appear to vanish into the abyss before any definitive glimpse can be captured. Modern researchers now suspect that deep sea giants, adapted to extreme pressure and eternal darkness, might be the living basis for these age-old tales. In another corner of the deep, the so-called vampire squid drifts gracefully through the dark waters. Despite its menacing name, this creature is not a fearsome predator, but rather a gentle wanderer, cloaked in a thin webbing that gives it an almost ethereal silhouette. Its body, adorned with bioluminescent organs, flashes fleeting hints of ghostly light, a signal that both lures prey and bewilders onlookers. This subtle, eerie glow is a survival trick honed by evolution in a place where every spark of light is a rare and valuable commodity. The vampire squid, with its paradoxical beauty and quiet existence, encapsulates the strange duality of the deep, a world at once both beautiful and foreboding. Then there is the enigmatic oarfish, a creature so slender and elongated it appears as if it were fashioned from liquid silver. Stretching up to 36 feet, the oarfish moves with a sinuous grace that seems to defy the laws of gravity. Sailors of old regarded its appearance as a portent, an omen of tumultuous times or even the anger of the gods. Although modern science attributes these sightings to the rare surfacing of a creature adapted to the vast, uncharted depths, the oarfish continues to be a powerful symbol of the mysteries that lie beneath the waves. Adding to the tapestry of deep, Sea phantoms are the ghost sharks, or chimeras, ancient creatures that have roamed our planet for over 400 million years. Their pale, almost translucent bodies and large, unblinking eyes grant them an otherworldly look, as if they were relics from a bygone era when the Earth was still forming its identity. These living fossils inhabit the cold, forbidding waters, surviving in a niche that few other creatures dare to occupy. Their very existence challenges our understanding of evolution and reminds us that the deep is a reservoir of ancient secrets waiting to be unraveled. Beyond these known entities, countless accounts and maritime legends speak of even more mysterious beings. One such tale recounts the experience of fishermen from a remote coastal village who, on a moonless night, observed a luminous figure gliding silently just beneath the surface. The creature's form was indistinct, wrapped in a shimmering mist that seemed to dissolve its boundaries. Its eyes, glowing with an uncanny light, stirred both wonder and unease among those who witnessed it. Skeptics suggest that such sightings might be optical illusions or the effect of bioluminescent plankton dancing in the deep current. Yet for the locals, these encounters are undeniable proof of a world that straddles the line between reality and legend. A key to many of these ghostly manifestations is the phenomenon of bioluminescence, a natural light show created by chemical reactions within living organisms. In the pitch black depths of the ocean, where sunlight fails to penetrate, bioluminescence becomes a language of its own. It is used to attract prey, communicate with potential mates, or simply to confuse predators. The anglerfish, with its eerie, dangling lure, is perhaps the most famous example. This creature's glowing appendage not only lures in unsuspecting victims, but also creates an image of eerie beauty that haunts the imagination of anyone who hears its tale. What is it about these deep, sea specters that continues to captivate us? It is their profound mystery. Despite the relentless advance of modern technology, submersibles, remotely operated vehicles, and advanced imaging, many of the ocean's secrets remain shrouded in darkness. Each new discovery in these abyssal depths challenges our preconceptions about life and forces us to confront the reality that our planet is still teeming with wonders beyond our wildest dreams. The relentless human quest for understanding drives us to explore these murky waters, to capture even the briefest glimpse of a creature that has eluded explanation for centuries. In these endeavors, science and myth converge. What was once dismissed as sailor's lore gradually gains scientific grounding, even as each revelation raises more questions than it answers. The ghostly inhabitants of the deep, with their uncanny adaptations and elusive behaviors, remind us that nature is not confined to our expectations. It is boundless, ever-changing, and full of surprises. In the final analysis, the realm of the phantom of the deep is more than a collection of eerie creatures and spectral sightings. It is a testament to the unyielding mystery of life itself. Every splash, every shadow beneath the waves, is a whisper from a hidden world, a call to keep exploring, questioning, and marveling at the intricate tapestry of existence that lies just beyond the limits of our everyday experience. As we continue to probe the ocean's depths, these ghostly beings serve as ambassadors of a world that is both timeless and transient. Their presence challenges us to rethink the boundaries between myth and reality, urging us to keep our minds open and our hearts curious. For in the dance between the known and the unknown, the spectral inhabitants of the deep remind us that the greatest mysteries often reside in the places we have yet to explore. Beneath the shimmering surface of our vast oceans lies a realm of explosive power and hidden marvels, an underworld where fire meets water. Let's begin by understanding what underwater volcanoes truly are. These geological formations are essentially volcanic vents that erupt beneath the ocean's surface. Just as their terrestrial cousins form mountains and shape landscapes on land, underwater volcanoes sculpt the seafloor, creating towering structures, ridges, and even new islands over time. One might picture them as nature's hidden forges, where the Earth's internal heat is released in spectacular bursts of energy. Their eruptions can be slow and effusive, gently building up the seed with layers of lava, or they can be violent and explosive, releasing plumes of ash and gases into the surrounding water. One fascinating example is found in the Pacific Ocean, along the so-called Ring of Fire. This area is notorious for its high volcanic and seismic activity. Here, underwater volcanoes are not merely geological oddities, but dynamic forces that continuously reshape the ocean floor. A prime case in point is the submarine volcano known as Westmatter, located in the Law Basin near Tonga. Westmatter has been observed spewing molten lava and creating a constantly changing landscape on the seafloor. Its eruptions, captured on high-definition video by oceanographers, reveal glowing lava fountains and dramatic bursts that light up the dark depths of the ocean. These underwater eruptions are not only visually stunning, but are also crucial for our planet's ecosystem. When a submarine volcano erupts, it releases a cocktail of minerals and nutrients into the water. These elements can spark a burst of life, feeding plankton blooms and setting off a chain reaction that benefits a wide range of marine species. The nutrient-rich waters create hotspots of biodiversity. In some cases, entire communities of organisms thrive around these hydrothermal vents, where the heat and chemicals provide energy in a process that remarkably mirrors photosynthesis on land. This phenomenon is known as chemosynthesis. Organisms such as tube worms, giant clams, and specialized bacteria form symbiotic relationships, turning a seemingly inhospitable environment into a thriving underwater metropolis. Yet, the influence of underwater volcanoes extends beyond the immediate explosion of life. These geological events play a vital role in regulating our planet's climate and even the chemical composition of our oceans. For instance, the steady outpouring of carbon dioxide and sulfur compounds from these eruptions can contribute to subtle shifts in ocean acidity. Although the impact of a single underwater eruption might be small, the cumulative effect over millions of years has been significant, influencing both the evolution of life and the long-term dynamics of Earth's climate system. Exploring the technological marvels that allow us to witness these events is another adventure in itself. Remotely operated vehicles, or ROVs, have transformed our ability to study underwater volcanoes. Equipped with high-resolution cameras and a suite of scientific instruments, these robotic explorers dive into the dark abyss to capture the raw power of volcanic activity. Their discoveries have revolutionized our understanding of seafloor geology, revealing not only the beauty of these undersea giants, but also their complex structure and behavior. For example, scientists have been able to monitor changes in the shape and size of volcanic formations over time, providing insights into the eruption cycles and the lifespan of these magnificent structures. The human fascination with underwater volcanoes is not merely academic, it has practical implications too. Many submarine volcanoes are located near tectonic plate boundaries, areas that are also prone to earthquakes and tsunamis. By studying the activity of these volcanoes, researchers can gain valuable information about seismic activity and potentially improve early warning systems for natural disasters. Moreover, the unique ecosystems that develop around these vents may hold clues to the origins of life on Earth. Some hypotheses suggest that the energy and chemicals provided by underwater volcanic activity could have sparked the first living organisms, setting the stage for the incredible diversity of life we see today. In addition to their role in shaping our natural world, underwater volcanoes have also inspired countless myths and legends throughout human history. Ancient mariners, witnessing the occasional glow beneath the waves or feeling the tremors of distant eruptions, often attributed these mysterious phenomena to gods or mythical creatures. Today, while science has demystified many of these occurrences, the romance of the unknown still lingers. The idea that entire cities might have once flourished near these volatile environments, only to be swallowed by the relentless forces of nature, captivates the imagination of writers, filmmakers, and explorers alike. For those interested in a more hands-on perspective, virtual deep sea exploration platforms now allow enthusiasts to experience the drama of underwater volcanoes from their own homes. Interactive simulations and 3D models, built on data collected by ROVs and submarines, offer a window into the subterranean world where molten rock meets the crushing pressures of the deep. These digital tools are not only educational, but also a source of inspiration for the next generation of marine geologists and oceanographers. To sum up, underwater volcanoes are much more than just a scientific curiosity. They are dynamic engines of creation and destruction, vital to the health of our oceans and the evolution of life itself. From the breathtaking eruptions in the depths of the Pacific to the intricate ecosystems that flourish around hydrothermal vents, these natural wonders continue to remind us of the power and mystery of our planet. Their study bridges the gap between geology, biology, and even climate science, offering insights that are as profound as they are beautiful. As we continue to explore and understand these underwater phenomena, we uncover not only the secrets of our blue planet, but also a deeper connection to the natural processes that have shaped life over billions of years. The next time you gaze out at the ocean, remember that beneath the calm surface, hidden volcanoes may be quietly writing the next chapter in Earth's ever-evolving story. This exploration into the world of underwater volcanoes is a testament to the endless wonders of nature. It challenges us to look beyond the surface, to appreciate the intricate balance of life and the immense forces that govern our planet. Let this be a reminder that science, exploration, and curiosity are the keys to unlocking the mysteries that lie deep beneath the waves. Beneath the ocean's surface exists a realm where nature's force twists reality itself. A domain sculpted by pressure so intense it challenges our very understanding of life. In the deepest trenches of the sea, every living being and every mineral formation is relentlessly molded by forces that would crush ordinary matter without a second thought. At depths reaching nearly 11,000 meters, the pressure surges to over 100 times the atmospheric pressure at sea level. This isn't merely a number, it's a transformative power. Under such extreme conditions, water behaves differently. The normally fluid and familiar properties of water alter subtly but significantly, affecting how heat is transferred, how chemicals interact, and even how sound travels. The entire environment becomes a stage for a drama where physical laws play out in extreme conditions. Consider the physical world first. As you descend deeper, the weight of the water above compresses every object, including the very structure of the sea. Rock formations and sediment layers are pressed into compact, almost unrecognizable configurations. The intense pressure not only compresses matter but also affects the solubility of gases. For example, oxygen and carbon dioxide dissolve more readily, which has profound implications for chemical reactions occurring in the dark abyss. In this high-pressure crucible, ordinary materials can behave in extraordinary ways, a challenge that scientists and engineers must overcome when designing deep sea submersibles and research equipment. Yet, perhaps even more fascinating is the biological transformation induced by these extreme conditions. Life at these depths is a masterclass in adaptation. Deep sea creatures have evolved unique structures and biochemical processes that allow them to thrive where most life would be crushed into oblivion. Their cells are not built like those of surface dwellers. Instead, their membranes are rich in specialized lipids that maintain flexibility despite the crushing force. Proteins within these organisms are carefully folded and stabilized by molecules like trimethylamine N oxide, a TMO, which counteracts the denaturing effects of pressure. Without such adaptations, the enzymes essential for metabolism would simply fail to function. Take the Hadal snailfish, for instance. This small, translucent fish, which resides in the Mariana Trench, is the poster child for deep sea adaptation. Its gelatinous body, lacking the heavy skeletal structure found in most fish, is perfectly suited to an environment where a rigid frame would only become a liability. The snailfish's tissues are engineered to be compressible yet resilient, allowing it to maintain buoyancy and function, despite the relentless squeeze of the deep ocean. Its survival strategy is not just about enduring pressure. It's about thriving in a habitat that is as alien as it is extreme. In a similar vein, crustaceans like the giant isopods have redefined the concept of endurance. Once thought to be remnants of ancient, giant sea creatures, these scavengers have adapted to life on the ocean floor by developing hard, armored exoskeletons that help them withstand the crushing pressures. Their slow metabolisms and robust, energy-efficient physiologies ensure that even in a world where food is scarce, they can eke out a living in the shadowy depths. But the impact of deep sea pressure extends beyond individual species. It reshapes entire ecosystems. In these lightless zones, energy is a rare commodity. With sunlight absent, most organisms rely on chemosynthesis rather than photosynthesis. Bacteria that metabolize hydrogen sulfide emitted from hydrothermal vents form the foundation of these unique food webs. These vent communities are microcosms of life's tenacity, showcasing how organisms can harness chemical energy from the Earth's interior. The pressure here not only influences the physical properties of the environment, but also dictates the available energy sources, leading to evolutionary paths that diverge significantly from those in sunlit waters. The interaction between deep sea pressure and biology has also led to astonishing evolutionary experiments. Many deep sea species display bioluminescence, a chemical light show that helps them communicate, attract prey, or deter predators in a world cloaked in darkness. The physics of light and pressure intertwine here, in the abyss, where even the faintest glimmer of light is rare. Bioluminescence becomes an essential survival tool. It's a striking reminder of how life can adapt creative solutions to even the most daunting challenges. Furthermore, deep sea organisms often exhibit slower growth rates and longer lifespans compared to their surface counterparts. In an environment where resources are limited and the metabolic costs of living under extreme pressure are high, patience becomes a key evolutionary trait. Every cell, every genetic instruction, is tuned to a rhythm dictated by the unyielding force of nature. Evolution here is not a race but a careful, measured process where every adaptation can mean the difference between survival and oblivion. The mysteries of deep sea pressure have not only captivated biologists, but also inspired technological innovations. Modern engineering has had to take cues from nature, designing submarines and underwater robots that mimic the resilient, flexible structures found in deep sea organisms. Materials science has evolved to create pressure-resistant alloys and polymers, ensuring that our technological probes can venture into these hostile environments without succumbing to the immense forces at play. Imagine a deep sea exploration vehicle descending into the dark depths, its reinforced hull bending the rules of physics, much like the organisms it seeks to study. Inside, scientists monitor data in real time, piecing together the puzzle of how life adapts to pressures that would crush unprotected flesh. Each descent is not only a technical challenge, but a journey into one of Earth's final frontiers. A place where the very concept of life is redefined. Every discovery in this realm challenges our assumptions about biology and physics. For example, studies of deep sea microbial life have revealed organisms that can repair their DNA in ways previously thought impossible. An adaptation that likely evolved to combat the constant stress of high-pressure environments. These insights are not just academic, they hold promise for biotechnology and medicine, offering clues about how cells might be protected from damage under extreme conditions, whether on Earth or in space. The profound influence of pressure on the deep ocean is a testament to the resilience and inventiveness of life. It reminds us that even in the most seemingly inhospitable places, nature finds a way to flourish. The deep sea, with its crushing forces and unyielding darkness, is not a barren wasteland but a dynamic, evolving ecosystem where every adaptation tells a story of survival against all odds. In summary, the world beneath the waves is a masterclass in adaptation and transformation. Extreme pressure not only sculpts the physical environment, compacting rocks, altering chemical reactions, and bending the rules of physics, but also drives the evolution of life in ways that are both subtle and profound. From the delicate balance of biochemistry in a Hadal snailfish to the robust armor of a giant isopod, every organism in this realm is a living testament to the incredible power of nature's forces. This exploration of deep sea pressure is more than just an examination of a physical phenomenon. It's an invitation to appreciate the intricate and often surprising ways in which life adapts to its surroundings. As researchers continue to uncover the secrets of these extreme environments, each new discovery not only enriches our understanding of the natural world, but also inspires new innovations that could transform our lives above the waves. Beneath the shimmering ocean surface lies a hidden realm, a place where light fades into a mysterious glow and life takes on astonishing forms. This is the mesopelagic layer, commonly known as the Twilight Zone, a region that stretches roughly between 200 and 1,000 meters deep. Here, the faint light filtering down from the surface creates an otherworldly environment where survival requires ingenuity and adaptation. At these depths, the sun's rays are so weakened that they become a dim, bluish haze, a mere whisper of daylight. In this environment, conventional vision is nearly useless, and the inhabitants have evolved extraordinary adaptations to thrive. One of the most remarkable strategies is bioluminescence. Countless species, from tiny plankton to elusive fish, produce their own light. They light up their surroundings in a silent, mesmerizing dance of sparks and glows, each flash a signal for communication, camouflage, or attracting prey. Take, for example, the lanternfish. Though small, these fish are incredibly abundant, and their shimmering, lantern-like organs serve multiple purposes. For some, this internal glow is a tool of deception, a technique known as counter-illumination. By matching the faint light from above, they can vanish into the twilight, evading predators that hunt from below. This clever camouflage is a brilliant adaptation to a world where every flash of light can mean the difference between life and death. Another intriguing resident of this dim domain is the viperfish, a creature as fearsome in appearance as it is efficient in its hunting. Its long, fang-like teeth and hinged skull allow it to consume prey much larger than itself. What truly sets the viperfish apart is the bioluminescent barbel dangling from its chin. In the endless dark of the Twilight Zone, this glowing lure is a beacon, attracting curious victims directly into its jaws. This method of luring prey underscores the constant battle for survival that unfolds in this mysterious layer of the ocean. Yet, the Twilight Zone is not merely a battleground of predator and prey. It is a world of delicate balances and subtle interactions. Here, many species have developed highly specialized organs to detect even the slightest glimmer of light. Some possess enormous, sensitive eyes capable of capturing the faintest photon, while others rely on a heightened sense of smell or vibration to navigate the inky waters. These adaptations offer a window into the evolutionary pressures that shape life in environments where every resource is scarce and every moment counts. Consider the hatchetfish, aptly named for its thin, silvery body that resembles a gleaming hatchet. Its entire structure is designed for life in the dim light. A flattened, laterally compressed body helps it slip through water with minimal effort. Its underside, often a mirror, like silver, reflects the scant light from above, rendering it nearly invisible to predators lurking below. The hatchetfish exemplifies the subtle art of survival, where blending in is as powerful a defense as any physical weapon. The mysteries of the mesopelagic layer extend far beyond these individual examples. This region plays a crucial role in the global ecosystem. The Twilight Zone acts as a massive conveyor belt, transporting organic matter from the sunlit surface to the deep ocean. Every day, vast amounts of dead plankton fish and other organic debris sink into these depths. Here, they become the primary source of nutrition for a complex food web that supports countless species. In a sense, the twilight zone is the engine room of the ocean's carbon cycle, a hidden yet essential component of our planet's climate regulation. Moreover, the life forms of the twilight zone have inspired human creativity in unexpected ways. Bioluminescence, for instance, has been studied extensively for its potential applications in technology and medicine. Scientists are investigating how these natural light-producing systems can be harnessed for developing new imaging techniques, creating innovative materials, and even treating diseases. The study of these creatures is a reminder of how much there is still to learn from nature's ingenuity, and how the secrets of the deep might one day illuminate solutions to challenges on the surface. The interplay of light and darkness in the twilight zone also serves as a metaphor for discovery. As researchers delve deeper into this enigmatic region, they uncover not only the secrets of the ocean, but also broader insights into the adaptability of life itself. Every discovery, from the unusual shapes of deep sea organisms to their unexpected behaviors, reveals a narrative of resilience and transformation. These insights encourage us to rethink our place in the natural world and to appreciate the intricate connections that sustain life on Earth. One of the most captivating aspects of exploring the twilight zone is the sense of stepping into a different universe. Advanced technologies, such as remotely operated vehicles, ROVs, and submersibles equipped with high-definition cameras, have allowed us to witness these phenomena firsthand. Footage of bioluminescent organisms flickering in the dark, of graceful creatures gliding silently through the water, offers a rare glimpse into a world that most of us will never see. This technology not only fuels our curiosity, but also drives scientific breakthroughs that continually reshape our understanding of marine life. In the coming years, as our exploration of the deep ocean advances, the twilight zone will undoubtedly reveal even more of its secrets. Researchers are optimistic that further study will unlock new mysteries about how life persists under such extreme conditions. These insights may one day lead to innovative solutions in conservation, sustainable fishing, and even climate change mitigation. The twilight zone is a frontier of science, a realm where each discovery adds a piece to the puzzle of our planet's vast and complex ecosystem. As we journey through these sunlit depths, it becomes clear that the twilight zone is far more than a shadowy, transitional area of the ocean. It is a vibrant, dynamic environment where life has carved out a niche in the interplay of light and darkness. The peculiar forms and behaviors found here are not anomalies, but rather testimonies to the incredible adaptability of nature. Every flicker of bioluminescence, every unique anatomical adaptation, tells a story of evolution under the harshest conditions. The allure of the mesopelagic layer lies not only in its scientific significance, but also in its ability to evoke wonder. It challenges our perceptions of life, urging us to consider that even in the absence of sunlight, the drive to live and thrive is powerful and unyielding. This hidden world, with its silent, glowing inhabitants, stands as a testament to the diversity and resilience of life on Earth. In this exploration of the twilight zone, we glimpse a universe that exists right beneath our oceans. A universe where light, though diminished, still holds the power to reveal beauty, mystery, and the extraordinary adaptability of nature. The mesopelagic layer reminds us that every corner of our planet, no matter how remote, has a story to tell, a secret waiting to be discovered by those bold enough to venture into the depths. This journey through the sunlit depths of the twilight zone is a compelling chapter in the larger narrative of our planet's oceanic wonders. A narrative filled with astonishing adaptations, interwoven ecosystems, and endless discoveries that continue to inspire awe and drive scientific curiosity. Our journey begins in a time when mighty empires thrived on land, but whose legacies now slumber beneath the waves. Consider the ancient city of Heracleion, once a bustling hub of trade in the Mediterranean. Overwhelmed by the force of nature and swallowed by the sea. This city now serves as a poignant reminder that time spares no structure. When archaeologists first discovered its ruins, they unearthed intricately carved statues, temple remnants, and even artifacts of daily life, all perfectly preserved by the cool, dark environment of the ocean floor. These relics not only reveal the architectural prowess of its builders, but also tell stories of lost traditions, economic networks, and cultural exchanges that spanned continents. As we descend further into these watery depths, another marvel awaits: the ancient submerged city of Pavlopetri, located off the coast of Greece. Thought to be one of the oldest known cities in the world, Pavlopetri offers a glimpse into early urban planning and community life. Winding streets, tums, and market squares, now covered in a soft veil of marine growth, whisper tales of a society that once bustled with activity. Marine archaeologists have painstakingly mapped the city's layout, piecing together clues from pottery shards and inscriptions that survived the relentless encroachment of time and water. The ruins of Pavlopetri stand as both an archaeological treasure and a testament to human resilience in the face of nature's inexorable changes. Submerged ruins are not solely relics of Mediterranean civilizations. Off the coast of India, the legends of Dwarka, a city intertwined with myth and history, also beckon the curious mind. According to ancient texts, Dwarka was a thriving port city and a center of power that eventually succumbed to the sea. Modern investigations, employing advanced sonar imaging and underwater drones, have uncovered structures that hint at a sophisticated urban landscape. These discoveries are reshaping our understanding of ancient trade routes and maritime technology, urging historians to re-examine long-held beliefs about early human settlements. The ocean, in its vast expanse, acts as a natural preservative. Salt water, cold temperatures, and the absence of oxygen in deeper regions slow the decay of organic material, allowing relics to survive centuries, or even millennia, almost intact. This natural time capsule provides researchers with an unparalleled window into the past. In some cases, entire shipwrecks have been found, laden with cargo, personal belongings, and even art, all of which offer insight into the lives of seafarers and merchants who braved treacherous routes. For instance, the Ulebrun shipwreck, discovered off the coast of Turkey, has provided a treasure trove of artifacts including copper ingots, intricate jewelry, and weapons. Each recovered item is a puzzle piece that, when assembled, paints a vivid picture of ancient trade, technology, and cultural exchange. But what is it about these submerged ruins that captivates our collective imagination? Perhaps it is the juxtaposition of nature's overwhelming power with the delicate, painstaking work of human achievement. The ocean's relentless rhythm, its ceaseless ebb and flow, reminds us of the impermanence of our own constructions, no matter how grand they may be. The ruins, now entombed in layers of sediment and marine life, evoke a sense of mystery, urging us to ask, what other secrets lie hidden beneath the waves? And what can these relics tell us about our own place in the vast tapestry of history? Modern technology has revolutionized the field of underwater archaeology, enabling us to uncover these secrets with a clarity that was once unimaginable. High-resolution sonar mapping, remotely operated vehicles, a REVISE, and advanced diving equipment have all contributed to a renaissance in maritime exploration. These tools allow scientists to document sites in extraordinary detail, creating virtual reconstructions that bring ancient ruins back to life. Through digital simulations and 3D models, viewers can now walk through the remnants of lost cities, exploring ancient streets and public spaces as if they were standing there themselves. This intersection of technology and history not only fuels academic research, but also transforms the way we experience and appreciate our shared heritage. Consider, for example, the vivid underwater museums that have begun to emerge around the world. These installations, set against the backdrop of ancient ruins, offer immersive experiences that merge art, history, and nature. They serve as a bridge between past and present, inviting us to reflect on the cyclical nature of civilization. The relics and ruins, once forgotten in the depths, now spark dialogue about cultural preservation, the impact of climate change, and the resilience of nature in reclaiming its domain. There is also an element of adventure and discovery inherent in exploring submerged ruins. Each dive is like opening a long, forgotten book whose pages have been written by the sea itself. The thrill of uncovering a centuries-old artifact or witnessing the silent majesty of a submerged temple is a reminder of our innate curiosity and desire to understand where we come from. These underwater explorations push the boundaries of human endeavor, challenging us to explore not only the physical depths of our planet, but also the depths of our historical narrative. In reflecting on these underwater treasures, it is impossible not to acknowledge the transient nature of human achievement. The ruins beneath the ocean are poignant symbols of both the impermanence and the enduring influence of our civilizations. They tell us that while human endeavors may fade with time, the echoes of our past continue to resonate, preserved in the silent embrace of the sea. As we conclude this segment, take a moment to visualize the scene. The interplay of light filtering through the water, the gentle sway of ancient columns, and the haunting beauty of relics left behind. Each artifact, each stone, and each inscription is a link to a bygone era, a chapter in the long, winding story of humanity. The submerged ruins are not merely remnants of the past. They are active participants in our ongoing quest for knowledge, inviting us to learn, to wonder, and to marvel at the resilience of history. Darkness, far from being merely the absence of light, has a curious way of nurturing life, a paradox that invites us to reconsumptions about what it means to thrive. In many natural and philosophical realms, darkness is not an end but a beginning, a fertile ground where transformation and regeneration take root. Let's consider a dense forest at night. While the daytime sun bathes the trees and undergrowth in radiant light, the nocturnal hours reveal a hidden world. In the deep shadows, fungi and insects emerge, performing roles that keep the ecosystem balanced. These organisms decompose dead matter, recycle nutrients, and even form symbiotic relationships with the trees themselves. This interplay of darkness and life reminds us that sometimes the most vital processes occur when visibility is at its lowest. This phenomenon is mirrored on a cosmic scale as well. Astrophysicists have long puzzled over Olbers's paradox, the question of why the night sky is dark despite an infinite number of stars. The paradox challenges our intuition. If the universe were eternal and unchanging, every line of sight should be ablaze with starlight. Yet the darkness we observe is not empty. It is filled with a canvas upon which galaxies, nebulae, and stars are painted. The dark void of space, then, is not a mere absence of light, but a dynamic backdrop that enables the dazzling emergence of life and creation. This cosmic interplay serves as a powerful metaphor. From the depths of darkness, brilliance is born. The paradox of darkness and life also resonates deeply with our inner human experience. Many cultures have recognized that periods of struggle and uncertainty, the dark nights of the soul, often precede profound personal growth. When life seems to be shrouded in despair, it is frequently during these times that individuals discover untapped reservoirs of resilience and creativity. Consider the artistic process. Many great works of art, literature, and music have emerged from moments of intense emotional darkness. Pain and sorrow can catalyze a transformation, giving birth to expressions of beauty that illuminate the human condition. This theme appears in nature's cycles too. Take the example of forest regeneration after a wildfire. The flames may destroy vast tracts of woodland, plunging the area into a temporary state of darkness and desolation. Yet, in the aftermath, the charred soil, enriched with nutrients from burned vegetation, becomes a nurturing bed for new life. Seeds that once lay dormant now sprout, and fresh growth begins to reclaim the landscape. Here, the darkness imposed by fire and loss becomes the catalyst for rebirth and renewal. It is a living testament to the paradox. destruction and darkness often set the stage for regeneration and growth. Philosophically, this paradox challenges our binary way of thinking. We tend to classify concepts like light and dark, hope and despair, as opposites, with one being good and the other bad. But in the natural world, these elements are interdependent. Without darkness, light loses its contrast and meaning. Just as a night sky filled with stars is defined by the surrounding void, the beauty of life is accentuated by the struggles and uncertainties that shape our existence. Embracing this duality allows us to appreciate that both light and dark have essential roles to play in the tapestry of life. Artists, too, have long been fascinated by this interplay. The renowned filmmaker Werner Herzog, in his documentary work, captured landscapes transformed by catastrophe. A desolate, almost surreal darkness that somehow evoked the persistence of life. His film, Lessons of Darkness, portrays the ravaged oil fields of post-war Kuwait not merely as a scene of devastation, but as a landscape that speaks of both loss and resilience. In Herzog's vision, the stark contrast between the scorched earth and the enduring human spirit invites us to reflect on how beauty and tragedy coexist, each giving meaning to the other. Even in our modern urban lives, the paradox is evident. Cityscapes at night reveal a different kind of vitality compared to their daylight persona. Neon lights and street art emerge in the darkness, turning mundane scenes into vibrant expressions of life. In the quiet hours after sunset, when the hustle and bustle recede, people often find moments of introspection and connection. The dark hours can become a time for creativity, reflection, and even rejuvenation, an opportunity to explore facets of ourselves that remain hidden under the glare of constant activity. Science, art, and personal experience all converge to teach us that darkness is not something to be feared or simply overcome, but rather a condition as our understanding of life. It reminds us that every end is intertwined with a beginning, that every period of obscurity is pregnant with the promise of illumination. The paradox of darkness and life encourages us to look beyond the superficial and to seek the subtle processes that fuel transformation, both in the natural world and within ourselves. In practical terms, this means recognizing that challenges and hardships are not merely obstacles to be eliminated. Instead, they are integral parts of our journey, moments that prompt us to innovate, adapt, and ultimately emerge stronger. When we encounter our own periods of darkness, we might recall the forest that flourishes after a wildfire, the starry night that accentuates the brilliance of galaxies, and the artistic masterpieces born from the depths of despair. These examples serve as a gentle reminder that the dark is not devoid of meaning. It is an essential stage in the cycle of creation. Ultimately, the paradox of darkness and life is an invitation to reframe our perspectives. It calls upon us to see darkness not as a void, but as a space full of potential, a realm where life can innovate, evolve, and thrive in unexpected ways. Whether in the silent workings of a forest at night, the cosmic interplay of light and shadow, or the transformative journey of the human spirit, darkness is not the enemy of life but its silent partner, guiding it toward new horizons. In embracing this paradox, we find that the interplay of light and dark is what gives our world its depth, its texture, and its beauty. It is a dynamic conversation between forces that, at first glance, seem opposed but are in truth complementary. And so, in the quiet moments of darkness, we are reminded that life, in all its complexity, is a continuous process of emerging from shadow into light. Always evolving, always finding a way to illuminate even the deepest void. By understanding and appreciating this paradox, we not only enrich our view of the natural world, but also empower ourselves to navigate our own journeys with resilience and hope. Deep beneath the surface, sunlight fades away and temperatures drop, yet life finds a way. The nutrient cycle in these depths is comparable to a highly efficient recycling system. Organic matter created in the sunlit upper layers drifts downward as marine snow, a continuous shower of dead plankton, fecal pellets, and other detritus. As these particles sink, they become the carriers of essential nutrients like nitrogen, phosphorus, and carbon. Once they reach the deep, they're broken down by specialized microbes, releasing these nutrients back into the water. This process, known as remineralization, transforms the organic debris into inorganic compounds that can later be transported back to the surface through ocean currents or upwelling processes. At the heart of this transformation are the deep sea microbes, unsung heroes that decompose the falling organic material. Unlike the vibrant life in shallower waters, these microscopic organisms work slowly but steadily, adapting to the low temperatures and immense pressures of the deep ocean. Their activity is crucial, as it not only recycles nutrients but also supports a chain of life that includes specialized deep sea fauna. These microbes, operating almost like tiny chemical factories, break down complex molecules into simpler forms that become available for other organisms. For example, when a sinking particle decomposes, it releases ammonium, which in turn can be used by other bacteria to produce nitrate, a nutrient essential for many deep water organisms. The concept of the biological pump is central to understanding deep ocean nutrient cycles. In the sunlit surface waters, photosynthetic plankton capture carbon dioxide and convert it into organic matter. Some of this organic material, rather than being consumed at the surface, aggregates and sinks. This downward transport of carbon is critical, not only for sequestering carbon dioxide from the atmosphere, but also for supplying nutrients to the dark ocean. The efficiency of this pump determines the rate at which nutrients are cycled through the ocean depths, and, ultimately, how much life the deep sea can support. Think of it as nature's way of redistributing resources. A slow, continuous conveyor belt that moves life's building blocks from one part of the planet to another. Adding another layer of complexity are hydrothermal vents. Found along mid-ocean ridges, these vents emit superheated, mineral-rich water. Unlike the nutrient input from sinking particles, the vent fluids are a product of geological processes. As seawater seeps into the Earth's crust, it heats up and reacts with the surrounding rocks, dissolving metals and minerals. When this heated water emerges from the vent, it creates a chemical cocktail that supports unique ecosystems. Organisms living around these vents rely on chemosynthesis, a process where bacteria convert the vent's chemicals into energy. This is a prime example of how life can thrive independent of sunlight, relying instead on the chemical energy provided by Earth's interior. The deep ocean is not static. It is a dynamic system where currents and mixing play crucial roles in nutrient transport. Thermohaline circulation, often described as the ocean's global conveyor belt, moves cold, nutrient-rich waters from the polar regions toward the equator, while warmer waters return northward. This circulation is essential for redistributing nutrients over vast distances and for maintaining the balance of life in the deep. Regions where these deep currents upwell are often hotspots of biological productivity. For instance, the upwelling zones along continental shelves bring nutrient-dense water to the surface, sparking bursts of life in areas that might otherwise be nutrient-poor. To put these processes into perspective, consider the journey of a single particle of marine snow. Formed in the surface layers, this particle might begin its descent as part of a massive, organic package produced during a phytoplankton bloom. As it sinks, it is grazed upon by zooplankton and gradually broken down by bacteria. By the time it reaches the abyssal plain, what was once a robust piece of organic matter has been transformed into a nutrient soup, a blend of nitrates, phosphates, and trace elements. These liberated nutrients then enter the surrounding water, feeding an array of organisms, from tiny microbes to larger scavengers adapted to the deep sea environment. This cycle, repeated over countless particles every day, underscores the efficiency and importance of deep ocean nutrient recycling. The deep ocean nutrient cycles have far-reaching implications beyond sustaining deep sea life. By sequestering carbon in the deep waters and sediments, the biological pump plays a significant role in regulating the Earth's climate. The slow recycling of nutrients and carbon ensures that large amounts of carbon remain locked away for long periods, mitigating the greenhouse effect. However, any changes in ocean circulation or surface productivity, driven by climate change, can have profound impacts on these cycles. Understanding how these processes work is crucial for predicting the future health of our oceans and the global climate. Despite decades of research, many mysteries of the deep ocean nutrient cycles remain unsolved. For instance, scientists are still exploring how variations in microbial communities affect nutrient breakdown and how shifts in ocean circulation might alter these delicate balances. Cutting-edge research involving remote-operated vehicles, deep sea sampling, and advanced molecular techniques is gradually unveiling the secrets of this underwater recycling system. Each discovery not only enriches our understanding of marine ecosystems, but also offers insights into the resilience and adaptability of life under extreme conditions. In the deep ocean, every element of the nutrient cycle is interconnected in a complex web of biological, chemical, and physical processes. The slow sinking of organic material, the meticulous work of microbial decomposers, the dramatic influence of hydrothermal vents, and the grand, scale movement of ocean currents all contribute to a symphony that sustains life in one of Earth's most inhospitable environments. This interplay demonstrates the profound interdependence of life on our planet. A reminder that even in the darkest corners of the ocean, every nutrient has a role in the larger story of life on Earth. In the silent hours of the night, while the stars above etch intricate constellations across the sky, an equally mesmerizing display unfolds in the depths of our oceans. Here, luminous creatures and subtle formations craft patterns that mirror the celestial dance overhead. As you listen, envision a world where the shimmering tips of coral and the graceful flickers of bioluminescent organisms form networks of light, not unlike the scattered brilliance of distant star clusters. Both realms, separated by vast distances and different elements, share a profound similarity in their design, a testament to nature's consistent artistry. At the heart of this phenomenon is the interplay of light, matter, and time. In the night sky, countless stars group together into constellations, visual narratives that have guided civilizations for millennia. Similarly, in the abyss, clusters of glowing plankton, drifting schools of fish, and the subtle interplay of underwater currents give rise to ephemeral shapes and lines. These natural patterns, formed by the gentle currents and the delicate balance of nutrients, can sometimes evoke the familiar outlines of galaxies, nebulae, and star clusters. Consider, for example, the way light diffuses through the water. When beams of moonlight penetrate the ocean's surface, they break into scattered rays. Much like the way starlight reaches our eyes from across the universe, the result is an aquatic tapestry of light and shadow, dappled reflections that hint at a cosmic order hidden in the deep. In both environments, light acts as a storyteller, revealing patterns that are as fleeting as they are eternal. Delving deeper into the science, we find that mathematics and geometry underpin both cosmic and aquatic formations. Fractals, a pattern that repeats itself at different scales, are a common thread. In the cosmos, fractal structures are evident in the distribution of galaxies and the spiraling arms of distant nebulae. In the ocean, similar fractal patterns emerge in the branching of coral reefs and the swirling eddies of underwater currents. Imagine a coral formation that, upon closer inspection, reveals tiny repeating patterns echoing the grand spirals of a distant galaxy. These self-similar designs, whether formed by gravitational forces in space or fluid dynamics in water, speak to a universal blueprint. This shared geometry is not mere coincidence. It is nature's way of organizing chaos into beauty, whether it be in the vast expanse of space or the confined mystery of the deep sea. Throughout history, humanity has looked to both the skies and the seas for inspiration and guidance. Ancient mariners navigated by the stars, and many early cultures imbued the night sky with myth and magic. Similarly, the unexplored depths of the ocean have long been associated with legends and mysterious creatures. The idea that these two distinct realms might share common patterns adds another layer to their allure. Take, for instance, the myth of the celestial hunter, whose constellation is immortalized in the heavens. In parallel, one can imagine a hidden underwater realm where bioluminescent beings form outlines reminiscent of that very myth. This intermingling of narrative and nature suggests that our stories, our myths, may be reflections of the physical patterns that pervade the universe. Modern technology has allowed us to peer into both the cosmos and the ocean depths with unprecedented clarity. Telescopes capture distant star clusters, while submersibles reveal the secret lives of deep, water ecosystems. Through these lenses, we see that both realms are far more dynamic and interconnected than we ever imagined. High-definition images of underwater landscapes reveal formations that seem almost deliberately arranged, as if nature were painting with a palette of light and shadow. In parallel, time-lapse sequences of star trails in the night sky evoke the same sense of deliberate artistry. Both images serve as a reminder that whether above or below, natural patterns have a rhythm and harmony that resonate with our innate sense of wonder. Artists and scientists alike have long been fascinated by the similarities between celestial and aquatic patterns. In art, swirling forms and intricate lines evoke the timeless beauty of both the starry expanse and the deep sea abyss. The fluid shapes found in impressionist paintings or digital art are often inspired by these very patterns, capturing the essence of a universe that is simultaneously chaotic and ordered. From a scientific standpoint, understanding these patterns can reveal much about the forces that shape our world. The study of turbulence, light refraction, and fractal geometry not only explains the patterns we see in the sky and the sea, but also helps us comprehend the fundamental laws of nature. This confluence of art and science enriches our understanding and appreciation of the world, suggesting that the universe might be following a single, elegant design philosophy. The uncanny resemblance between the starry skies and the patterns in the ocean abyss invites us to ponder our place in the grand tapestry of existence. Whether we gaze upward into the cosmos or dive into the enigmatic deep, we encounter forms that speak to the unity of natural laws. This realization can inspire a profound sense of connection, not just between different parts of the natural world, but also within ourselves. Consider the way our minds are wired to find patterns. This cognitive tendency has enabled us to connect dots, form stories, and create meaning from the chaos. When we witness the recurring patterns in both the heavens and the oceans, it serves as a reminder that our search for meaning is mirrored in the very fabric of the universe. The patterns are not just visual phenomena, they are symbols of the interconnectedness of all things. As we draw this exploration to a close, take a moment to reflect on the beauty and mystery that pervades both the night sky and the deep sea. The celestial reflections that manifest as star patterns in the abyss are a testament to nature's infinite capacity for wonder and symmetry. They remind us that no matter how vast the universe may seem, there is a consistent thread running through every natural formation, a thread of light, pattern, and unity. Let this vision of intertwined cosmic and aquatic beauty serve as an invitation to explore further, to seek out the hidden connections in our world, and to marvel at the timeless dance between light and matter. Whether you are an avid stargazer, an underwater explorer, or someone who finds beauty in the smallest detail, the story of celestial reflections offers a profound perspective on the artistry of nature. In the end, the patterns we see, both in the boundless cosmos and in the shadowy depths of the ocean, are not merely coincidences. They are echoes of a greater design, a silent dialogue between the forces that govern the universe. And it is within this dialogue that we find not only the secrets of distant stars and hidden oceanic wonders, but also the reflections of our own innate curiosity and creativity. So, let this exploration be a reminder the universe is a mosaic of light and shadow, where every ripple in the water and every glimmer in the sky tells a story of connection, beauty, and infinite possibility.